Hi again. Welcome to the first of two videos on financial loans analysed with geometric series. Here we discuss the way to monitor the interest charged against the amount still owing to determine how much our regular repayments should be, and also how to estimate our maximum realistic loan given our financial restrictions that we are not as wealthy as we would like to be. There are many types of questions we can ask related to loans. How much will the repayments be each month? How much can I afford to borrow? What happens to my repayment amounts if I miss a payment or two? How long will it take me to pay off a loan? What effect will it have if I pay off a little extra sometimes? An important question in loans as well as in annuities is to determine when is the interest going to be paid. And to answer this, ask yourself, who held the money during the period? If it's in an annuity, the fund held your money, so they must pay you interest. If you hold the money, as in a loan, then you must pay the interest on all the money that's out for the previous period. Also remember that interest is paid and charged before the next payment is made, unless of course there are special agreements. So the first question is going to be to establish how much is the regular repayment in a normal loan. Well, let's take the example of poor Chris. Chris needs to borrow $1,500 from his bank over 1 year for urgent car repairs. He's being offered a reducible interest rate of 6% per annum, compounded monthly. How much will Chris have to pay each month? So we'll just summarise that. He is going to borrow $1,500. The interest is 6% per annum. The term of the loan is 1 year, which is 12 months. So we'll let his monthly repayment be R. Now, you've got to be able to go through the steps. Please talk to yourself about what's happening in each step and get the sequence correct. At the end of month 1, Chris owes the amount he borrowed plus the interest he must pay for having had the money for the previous month, minus the repayment he makes after the interest is charged. So we can write that down and say at the end of M1, Chris owes $1,500, the money borrowed, times 1.005, which is the interest rate, including the original amount, of course, minus R, the repayment. At the end of month 2, Chris owes the amount he owed at the end of month 1, plus the interest he must pay for having had the money during month 2, minus the repayment he makes after the interest is charged at the end of month 2. So we can write that as the amount he owed, which was $1,500 times 1.005 minus R, and then times the interest, 1.005, minus his second repayment. So we can expand those brackets and say the first 1.005 goes to the one outside it to give us 1.005 squared, times the 1,500 of course. And then the second expansion is minus the R times the 1.005, and then the minus R remains just as it is. At the end of month 3, Chris owes everything he owed at the end of month 2, which is 1,500 times 1.005 squared minus R times 1.005 minus R. That's what we got in the end of the previous bit. And then we multiply all of that by another interest payment, so times 1.005, and then take off his third repayment. Now we can expand that using our loops again. So the first bit is 1,500 times 1.005 squared times the 1.005, which gives us the 1,500 times 1.005 cubed. The next bit is the R times 1.005 times the outside 1.005, so that squares that term, and then minus R times 1.005, that just goes straight down, minus the third repayment. Now we can factorise all of that, leave the first bit alone, can't factorise that, so that's 1,500 times 1.005 cubed, but the R can come out, or the minus R can come out of the other three terms to leave us with minus R outside of 1 factorising backwards, plus 1.005 plus 1.005 squared. It's interesting to look at these two terms. The first one is the amount Chris would have owed with no repayments. So that's just a straight ordinary run-of-the-mill compound interest formula, just that. Now the next part is a geometric series showing the increasing value of the earlier payments. So very important. Let's have a look at what we've got. It's the end of month 3. The first term in our expression is 1500 times 1.005 cubed. And we look at our geometric series and we find that there are 3 terms, 3, 3, 3. So we can generalise this. At the end of 12 months, we're just going to replace the 3 with a 12. So Chris owes $1,500 times 1.005 to the 12th minus the repayment, and then we use our geometric series sum and 1.005 to the 12th over 1 minus 1.005, and of course at the end of 12 months that's a zero balance because he's paid his loan back. So we put that in our calculator just straight off, you can see that, and the repayments turn out to be $129.10 per month. Just as for our annuities, the normal procedure in analysing the loans is to develop equations for the first 3 months. If there's nothing untoward, then we can generalise by incorporating your sum of n terms geometric series formula. If there's something that's a little bit different, as there will be in the next video, then we can go a couple more terms just to establish the total pattern. The second kind of question is to find the amount which we might be able to borrow given our financial restrictions. And to show you how this can work, I'll tell you about my friend Grace, very good friend, and she now has her licence and she wants to buy a reasonable second-hand car for something like $14,000 to $17,000. She wants to take out a loan and can afford no more than $500 per month for the repayments. She can take out a 3-year loan with the bank at 6% per annum with monthly reducible interest. So can Grace do this purchase of the car as she wants? Again, we just summarise the essential aspects of this problem. We've got to find the possible loan amount, and she's able to pay $500 in repayments. The interest rate is going to be 6% per annum, which translates to 0.5% per month, and the term is 36 months. So let's go. The balance at the end of the first month for Grace is going to be the amount that she's going to borrow times the interest, 1.005, which includes the original component plus the interest component, of course, minus the repayment of $500. At the end of month 2, she has all of that still owing, A times 1.005 minus 500, to which we add some more interest, so multiply by 1.005, and then subtract the repayment. If we expand all that, like we did before, then it's A times 1.005 times 1.005, which is A times 1.005 squared. We've got a minus 500 times 1.005 and then a minus 500. So that's good. We now can see what's happening. At the end of month 3, there's all of that, so we just copy that down, multiply it by the interest again, 1.005, minus the 500 again. It's all the same. We've just got to talk to ourselves about what's happening. We expand that in the normal way, and we notice that the first term is going to be A times 1.005 cubed minus, now the 500 is in each of these terms, so we're going to take out the 500 as a common factor, take the factors in reverse, and we're going to have 1 plus 1.005 plus 1.005 squared. So good. Again, we've got our first term, which is what Grace would owe if she made no repayments, and the second term is a geometric series in 3 terms. So now we're going to generalise those 3 terms to 36 terms. So the balance at the end of month 36, 3 years, is A times 1.005 to the 36 minus 500, sum of n terms of a GP is 1 minus 1.005 to the 36 over 1 minus 1.005. At the end of 36 months, all of that's 0, so therefore we just split those two terms across the equal sign. A times 1.005 to the 36 is equal to all of that stuff, and then we just divide the right hand side by the 1.005 to the 36. Stick it in your calculator. There's my calculator, and I find out that she can, to the nearest $10, Grace can borrow $16,440. So yeah, Grace can do what she wants, which is great news for her. There are our first two loan situations. Hope you now feel a bit more relaxed about analysing a loan. Loans are good things as long as you get rid of them as quickly as you can. We all need them, but some people do not recognise they can be dangerous if not handled positively and systematically. In the next video, we discuss other variations to a normal loan arrangement. In the meantime, consolidate what you have learnt here by doing the loans test yourself 1, then come back and see me. Hit the like button and subscribe if you haven't already. Good luck. See you in the second loans video shortly.